brief summary overview of what Land PKS is, and then Jeff's going to do an awesome live action demo. But I just want to start with the premise of mobile phone technology and how mobile phones are really kind of a new emerging tool, especially in developing countries. So we've seen in the US, mobile phones can change how we do business, how we communicate, how we date, all kinds of stuff. But in a lot of countries, mobile phone use is still really rapidly picking up. So you can see specifically like this right here. So especially people using mobile phones to access the internet and to access information is growing more rapidly in Africa than it is globally. And that's particularly because people don't have access to a computer, to fixed internet. So really mobile phones are the way that a lot of people in developing countries access information. So we're really playing on that in Land PKS as far as providing people with information who maybe wouldn't be able to get that information otherwise. They really do rely on their mobile phones. So just kind of very generally, Land PKS, we are developing a mobile app for site-specific information for sustainable land management. This is a list of some of our partners. I'm sure there's a few missing, but they're all helping us domestically and globally both develop these apps and then implement them in the field. So we currently have 2 modules. You guys might be more familiar than others, but we have our land info module, which walks a user through how to hand texture the soil. So how to determine if it's a clay, if it's a sand, and then the land cover module walks the user how to monitor vegetation. So how do you monitor vegetation change over time? And this is really powerful, especially in places where people don't have the technical training and don't have access to information. You don't need to be a soil expert to actually go out, texture the soil, and figure out what kind of soil you have. And that's really important for making decisions on your farm or decisions with your land. This is kind of a general schematic of how Land PKS works. So you have your phone, you have Land PKS downloaded. Most phones now have camera, GPS. And with that, you can use our 2 modules, land cover and land info, to enter data about your land. Whether that's soil data, vegetation data, and then Jeff will cover some future modules as well. And then from that, you get results. So right now we have climate data. You actually get that immediately. So just by entering the GPS location, you get climate data. You get nothing. You get something for doing nothing, which is great. We have soil output, so you get kind of a basic outline of what kind of soil you have, what the texture of the soil is. Shawn might talk a little bit about our available water holding capacity features that we're adding as well. And then land cover. So you do get graphical outputs of the land cover, and that's delivered on the phone instantly. So someone can enter data and immediately see, oh, this is how my land looks, and this is how it's changing over time. This is the potential of my land. And then use that information to kind of close this loop. So to then use that information to make sustainable land management decisions. And a lot of the things you enter into Land PKS are things you can do more than once, especially when you're looking at vegetation change over time. You might want to continually enter data and continually adapt how you're managing your land. Some of the very basic benefits, we are developing this to work globally. Anywhere in the world it should work. It's free to download and use, which is particularly important in resource-limited contexts. So if you don't have the money for fancy soil sampling, that kind of thing, you can use Land PKS, and it's free to use. As I just mentioned, the results are delivered to the phone, but you can also upload your data to the cloud, and it's stored on our data portal. So if you have 100 different Land PKS plots that you've done, you can download that and analyze it however you might want to analyze it for what you're doing. And that is open source data, so you could actually download all of the plots all over the world and kind of compare what different places look like as well. So I'm just going to provide a really brief intro to both of these modules in a bit more detail. So the land info module, these 2 pictures on the right are from Tanzania. So on the farm on the right, we were digging a hole there because it's an incredibly productive farm. Look how high that corn is. So we wanted to see what kind of soil is this. And then the middle, this is actually an agricultural extension agent in Tanzania, and she's really motivated, but she's a jack of all trades. She does livestock, she does ag, she was vaccinating cats and dogs. So she's not trained in soil science necessarily, and she was actually, you can see the smile on her face, really amazed that she could hand texture the soil using the Land PKS app. And that's information that she can't get otherwise, but she can make recommendations based on that. So that was really exciting for her to see. So an example also from the work we did this summer in Tanzania, we dug 3 different Land PKS plots in this village. And these are maybe 100 yards apart. They're really not very far apart. So you would expect them to be maybe different or maybe similar. But in fact, we found that these plots differ really significantly. So available water holding capacity is an output that you get from land PKS, and it varied a lot. So you have the lower field here. It's kind of a slanting landscape, had a significantly higher water holding capacity than the upper field, and this is going to have implications for agriculture in that area. If you're a farmer farming on this upper field, you might want to make some different decisions than the farmer on this lower field. And then also really important is the forest plot. So this has by far the lowest water holding capacity, and that's important when you're dealing with issues of conservation, because this really shows that it may not be worth converting that forest to agriculture. It might be more productive to just leave it as it is, which is hugely important because agricultural conversion is a huge destructive force as far as conservation goes. So an example of land info here, this is Jeff's house, and this is his neighbor's land, and they have pecan trees, and there's these two trees that are right next to each other, planted at the same time, irrigated in the same way, but they have drastically different yields, which is really interesting. So why would that might be? So Jeff went out there and, of course, did land PKS, and found that while these soils are actually in the same soil map, they are same soil map component, I guess, they are very different. So you have a loam here and a sand here. So the sandy soil, and that's the available water holding capacity over there. The sandy soil is not, holding the water quite as well, which is why it has a much lower yield than the loamy soil. So this might then help you make management decisions. So you say, hey, I can make this more productive by irrigating it more frequently, but irrigating it with less water as far as kind of even out those yield differences. So that's land info and some of the benefits of land info. For land cover, here's a few photos down here. This is Michaela Blennerman, who's a professor in geography. She was in Kenya working with me this September. And I'm just going to go over how you actually run through land cover, but using just a stick and the phone, you can monitor vegetation cover, which is also really important in resource-poor contexts as far as not having a lot of equipment. And this is really beneficial as far as monitoring conservation practices, monitoring restoration projects, monitoring invasive species. There's a lot of different reasons why you might want to monitor vegetation. So David Kimiti, who some of you might know, he's been using land cover a lot in Kenya, and specifically for his dissertation, and he's been using it in these conservancies in northern Kenya as far as looking at matching treatment and control sites. So there they're doing mechanical clearing of the cicacia species. So the cicacia species is growing significantly, and this is a problem because it's not palatable for livestock and for wildlife. So they're clearing that, and then he's monitoring how the vegetation's regrowing, how the perennial grass is regrowing. So he's doing that to match treatment and controls, but also using the land cover to assess vegetation growth as well. So we also are working with the Asambro Institute here, you might be familiar with, to develop curriculum as far as using land PKS as a tool for education. So we found, both in the US and abroad, that using land PKS can help with, you have here science, math, social studies, have students learn how to interpret graphs, learn about the impacts of soil erosion. There's a lot of different advantages to using land PKS in education. So we're working with them to develop a K-12 curriculum, which will be online and free and available for others to use. And we're using local US standards, as far as these are some of the education standards, to help ensure that this curriculum is up to the top notch, I guess I'd say. And then this also can be used globally. So we're developing it here to be used in the US, and then it can also be used for students other places.
So basically this is the entry screen. You do need to log in with a Gmail account. Provide a Gmail account to it. You can make up a Gmail account specifically for this or use one you already have. And basically you're going to give it a name. And so we'll call this JER test. And then for my location, I can go ahead and ask for the fix, and it's already, it's been sitting here for a while, so it's already about as accurate as it's going to get inside of a building. So I go ahead and say use, save, And once it's saved, it's actually going to take me to a screen with 2 tabs. And those 2 tabs are the report tab and the data input tab. And so Amy said, you get something for free as soon as you've hit your location and saved the plot, it automatically pulls down the climate, the long-term climate record of that region. Okay, so if you're someplace, you're not familiar with the climate, you're trying to figure out what the ecological potential is, this is a good way to get a good handle on it. There's a little more information, total annual precip. This is the World Climb database. We will probably be switching to PRISM, which should give us a more accurate representation here. I'm not sure where the 270 is coming from, but I wish we had 270 millimeters around here. And we actually found, I was in Lima over Thanksgiving, Lima, Peru, and the same thing was being overestimated. So I can go back to my list of plots because I hit the wrong button, and go to my JER, which is now saved. Here we go, JER text, and now actually it has, it's actually given me, and there will be a location showing where we are in the future, so you're able to kind of confirm that you're actually on the right plot if you're trying to go back to a plot in the future. At this stage then, I go to land info, and there's no information there. In the future, there will be the soil map unit components that, based on your location, will be identified here. But if I want any sort of value-added information, I've got to go over to data input, and I can work my way through any of these screens. And the way this new one, for those of you that have used it before, the biggest difference between the new version and the old version is that you can rapidly move between the data input and the report screens. You don't have to go through everything. You can just pick and choose what you want to do. And so there are various screens for just describing sort of what's there, whether you've got grazing or not, what's grazing it. You can see that we had to add some like pigs and various forms of wildlife for the Africa version. Soil texture is really the main one, and that's by getting texture by depth. In one of the future versions in the next 6 months, it will actually then identify your soil map unit components. It will identify your soil. So rather than just going to soil survey and saying, oh, I'm in this map unit, and like my neighbor did, assume that he can plant his pecan trees and irrigate them the way that everybody else around us was irrigating their pecan trees, realize, oh, actually this soil here is a sandy soil and I'm going to have to irrigate it a lot more often. Okay, so we really do see this as having a lot of domestic applications for small farmers and people like myself and my neighbor who have just an acre or 2 of land and are trying to figure out. So basically this leads you through the process of describing your texture by depth. I can select the texture, or if I don't know, I can ask to guide me, and I can go through a key. And if I'm not sure what it means by don't form a ball, and this is Amy was talking about with the extension agent who's working in Tanzania, it actually leads you through the process of doing that. I've got my loamy sand. I'm going to select a gravel content. I go down to the next depth, and I'm just going to pick a few here. Next depth, and at this stage now, if I go back, I can actually go to my report, and I go to land info, and it's already telling me what an infiltration rate is. So once I've got 20 centimeters of data, it will calculate my infiltration rate, likely for that soil, and I can actually play around with the organic matter content and basically predict what will happen with increased organic matter content. So this is really important for motivating people to manage their soil for better soil health, which is something that's really being pushed now by NRCS. But it's not getting my AWC to a meter. We want people to give us at least 50 centimeters of data, and then we predict what the last 50 centimeters will be. So if I go back here to the data input screen, I say, well, I'd really like to know that. I add the 20 to 50 because somebody else dug the hole for me. And I go back to the report, and immediately it's updated. And we're still working on this algorithm. This equation is off right now. But basically, you're able to play around with that. So then, in addition to we're constantly adding modules, but the other module that's here is something called the land cover module, which is the one for getting basically data that are compatible or largely compatible with data that Sarah McCord and her group are collecting through AIM for the BLM, but a lot simpler. So we can, by species, we only allow people to record 4 species, or we only provide an opportunity for them. They can put in notes, whatever they want to. But we basically just allow them to identify species, and of course, our dominant species are mesquite and creosote bush, not always on the same site, probably, and our non-woody species and so forth. You can put whatever you want in. And then, whoops. These are basically set up sort of like a typical AIM or NRI plot, except instead of laying out a tape transect, you just drop those sticks on the ground that Amy was showing in her pictures. And so you've got a stick, a yardstick or a meter stick with 5 marks, and this is line point intercept, except with a stick. And so you walk out 5 paces, you drop the stick, you record at each point. I have, in this case, I have tree over rock, and then I've got a couple of bare ground, and at the next one, I just have woody litter. And I can swipe over and record maximum height as we would for NRI or AIM. And we're actually going to put up, right now there's, and this is getting a little bit into details, but this is where the Hornada's research really drives how this is being developed. So it took us a long time in NRI and AIM to figure out how best to measure height, so that it would make sense for the wildlife folks and the wind erosion folks like Nick. And it turns out we implemented it differently in here initially. We said maximum height in the meter square. And so what we're going to do is add an option here where they can specify whether they're recording that or whether they're recording something that is in that 30 centimeter diameter that then Brandon can use for his modeling for wind erosion. Gaps can get recorded here as well, and then species density over here. And then you go through, and it turns out it takes about 1 minute per stick. It takes about 20 minutes per plot. So, you know, and that's often how long it takes to lay out tapes, right? At least when I lay out tapes and trying to wind things through. So it's a lot faster. Obviously, the data are not nearly as precise, but they are compatible. So you can actually compare to existing data. We can add photos. You can add notes at pretty much any time, and it updates, and we'll be using this note function in the future to provide feedback to NRCS and BLM on some of the things.
Well, my new title is apparently Head of Research for Land Potential Knowledge System. It's a very thankless title, but I was tapped with sort of talking about some of the tie-in applied research and existing knowledge bases that really has come to support this app development. And it's a technology development project, and because of that, it relies on applied research and taps into that existing knowledge. If it was easy, Google would do it. Or, as Jeff likes to compare himself to Elon Musk, you know, SpaceX would develop this project. But Hornada is really uniquely suited because we do have access to the research arm, New Mexico State, University of Colorado, to be able to tie in to these different skill sets, to, you know, the 3 people out there that actually understand soil survey or how ecological sites are developed, has been really important for this whole total app development. One example of tapping into existing research, a couple of ARS scientists with the USDA Salinity Lab developed this set of pedotransfer functions where you could take soil texture and to be able to show what the effect of organic matter has on available water capacity and filtration. They put together this little app, web app, a number of years ago, and we wanted to take that and implement it into our app so that you could see, you know, be able to slide, you know, what percentage of organic matter and the direct impact that would have on available water capacity. This was something that we wanted to implement. The prior version would actually take the texture data, ping it to a server, run the Rosetta model, and then give you back your available water capacity. When we sort of proposed this approach, it was all app hosted. The algorithms, you know, are designed into the app, and it has that kind of immediate calculation of what organic matter brings to infiltration of available water capacity. When we proposed this, the programmers were pretty excited because that took some load off the servers And we're still working with the algorithms. I think there's a decimal place off here or there. Some other work that I've been involved in is sort of this soil hand texture test. And if you've done hand texturing in the United States, you were taught this method. It was developed by some Kansas State soil scientists. It's very different than the international system, but it has sort of this neat flow where, does it form a ball? Does it form a ribbon? How long is the ribbon? And then is it gritty or smooth? One of the problems of that, if you do some network analysis, once you kind of go down this trunk based upon ribbon length, you're sort of isolated. And the novice soil scientist, the way they hand texture, they don't realize that, that length of ribbon doesn't sort of pull you down this flow diagram. It really is sort of this gradient. So some research that we did that a number of people in this room was a part of was to look at sort of this probability of if you got grittiness class incorrect or ribbon class incorrect. And we used the National Cooperative Soil Survey database for hand texturing and laboratory to find that professional soil scientists really don't have a difference, with this probability that if you get it wrong, is it tied to ribbon length or grittiness. But we used some LPKS data and some BLM AIM data, people who may not have that same experience, and we find out that consistently, if they got it wrong, it was due to the ribbon length, not necessarily the grittiness class. So one of the next versions down the road with the next release is to implement these additional soil texture tests. The idea that you're not necessarily isolated down the trunk of the flow diagram. What that may mean is, instead of ribbon, worm it out and bend it, based upon the cohesive properties of clay. You could actually figure out what texture class you're in, or even like a redundant test, like put your fingerprint in it. That actually could separate a couple classes within that ribbon length error. The other really exciting thing that we're hoping to implement is to be able to use the smartphone to take a photo of the soil and to be able to get Munsell color. There was a paper that came out just this last year by someone of our team and with some soil data collected by people in this room, to where by taking a photo of the soil color with a calibration card, you could actually get at the Munsell color. There's some issues with lighting. You have to make sure that there's even lighting. There's some other issues with if you don't smooth the sample out to be able to create shadows, so certain minerals will reflect if it's in direct light, or like big sand grains will cast shadows. That's just some minor error that we're trying to figure out through instructional material, but this is really exciting. Because a Munsell color book costs $300, and we wanted to make this more accessible. This is sort of a standard calibration card. What we're trying to push is this Y-Val card to be able to calibrate it, but sort of like the next ninja level is to use a sticky note, something that you can calibrate, maybe in your office, and then when you go out, you could use a sticky note, with a known color, so you have to know the color of that sticky note, but something that could be thrown away, get dirty, and it not necessarily matter. So this is the Salley family farm, going back 2 generations in western Kansas. You have this kind of complex mosaic of soils. A playa system, your classic mollisol plains. Quarter section, there's a number of very, very different soils. You sort of have these sand sheets that blew up during the Pleistocene from this playa when it was dry. You have this more rich mollisol environment. So in this really kind of complex mosaic of different soils, it is complicated in how you manage it. This was a 2016 aerial photograph where was the once decade rain, apparently in April, where you can actually spot these differences from where it's really green versus in these sand sheets where it's not as productive. So if you were to dig a soil pit right outside of the family farmhouse, say you wanted to install a septic tank, to be able to see if you're in that sandy environment or that more clay-rich mollisol prairie environment, Land PKS, the way it's structured even right now with the version out, you could actually look at the available water capacity of these different systems. But I wanted to use this as an example for what we're kind of wanting to show for the soil ID component. So here it is, the farm, there's a yellow soil pit. With Land PKS, as you go through your soil pit, you dig a hole, you get texture, hopefully you get color as well, and you can compare that to the top predicted map unit components. Here, there's really three main soils, one associated with the sand sheets, one associated with the prairie, and then one associated with the playa. Based upon this, it pings the Dalhart fine sandy loam with 86% probability. That immediately opens your knowledge system up to land capability class, ecological site. In this case, you have a very pixelated ecological site. It's not grassland, it's converted land use to cropland. But to be able to use your soil pit, find your soil class, and then have access to the ecological site really is that next level that Land PKS is going to move into. And we're still working out the details, but we've shown this example to a number of people with NRCS and other stakeholders, and they're very excited about if we can get it work. The big issue from the user experience, the programmers don't like this horizontal presentation. So the next thing that we need to figure out is how to display this. But I wanted to show this just as an example. The previous soil web, I don't know if you've used it, really is just geographic based. And this app is no longer supported, but we are trying to bring in some of the ideas of soil web into our soil ID. But it pings your GPS, elevation, whatever soil map unit you're on. So you can get some of that information without digging a soil pit, but being able to predict what component you're on, you do have to dig a pit with some basic level information. We want to have sort of these users or these strength bars of your prediction, or even just a completeness of your own soil pit. And hopefully have color, texture, pH, open it up to some of these other soil collection metrics. This is by no means a complete list of everything going on, but there is a lot of research being supported with Land PKS, with global erosion models, the soil ID that I talked about, some work that's just come out in the last year with David Comiti, the soil color components. We're trying to do both domestic and international. So soil survey, the Sergo product isn't available globally. So we're having to work with some of the systems developed by the FAO and other systems and just trying to bring that into the same framework. But there's a lot of research, there's a lot of partners, and a lot of pieces have to move together to come together for this total vision. And I think we're getting there.
To give you an idea of what our website looks like and the data portal. So this is our shiny new website created by Heather. And so we're highlighting our current plot or our current places where we have some data, and then also where we're currently collecting a lot of data that we have stories for. But as Amy mentioned, we have our data portal where you can view your data and actually download it. So whenever you upload your data from the app, you can view it on here. You can play around with some visualization and mess around with your data, compare it to other plots, but then you can also download everything that you collected and have it for yourself to run your own analysis on.
So with regard to ecological site and state transition model connections, Shawn already sort of showed a potential connection there. One of the other programs that we're working with the National Ecological Site Team, the components of which that are here are Joel Brown and Curtis Talbot, is to enable, use Land PKS as a tool to access lots of different kinds of information. So it can produce information on soil texture. It can produce information on climate and maybe some cropland management, ideas that are related to available water holding capacity. It can also be a way for people to better access very specific information that are contained within ecological site descriptions. So, for example, you're out in the field, you go through that soil probability, that soil component identification algorithm. You collect the soil data. It matches it, as Shawn just showed, to the best matched component.
That then connects you to an ecological site or an ecological site group through NASIS, because the map unit components are correlated in a database to the ecological sites. And then once you have the cover, so right, if you had used the land cover, okay, yes, land cover app, getting all the acronyms wrong, and then you could use that information to go through a key, and this is a key that we're developing within the edit database, this ecosystem dynamics interpretive tool. So maybe this lives within land PKS, maybe it talks to edit down the road. And then you could go through this key out the ecological state, and then once you're in, you know which ecological state you're in, perhaps what community phase you're in, then it connects to all sorts of information that are linked to that ecological state, ecological site combination that might pertain to a number of different management interests. For example, you know you're in the reference state. These are some critical values that have to do with distinctions that you need to look at on the ground that are important for grazing management. You might move over to another tab. Maybe you're interested in brush management. Maybe you, through the key and through the description of the state, you're alerted to the potential dangers of a large number of small shrubs, and you're wondering what to do about that. And that information would be contained at present in a text narrative associated with those critical values that are referenced for that ecological site and state, and might eventually relate directly to conservation practices. So this is, I think, a way of saying that not only are you going to get direct information from land PKS that could be useful, but this could also be a portal to other sources of information that rely on information having to do with climate, soils, and vegetation. So I'll turn that back over to you, Jeff.
So that really is sort of the nutshell of what we are trying to achieve with land PKS, and sort of how it's ultimately rooted in what the Hornada is about, which is really understanding how to better match use with land potential based on understanding of ecological processes. So the LTR work and so forth. And this concept here of how do we connect people with the right knowledge, and then how do we increase that knowledge, is something that everybody in this room is working on in one way or another. This is simply one to try to implement that vision. What I want to do now is just sort of give you a taste of what we're currently working on now for the next set of sort of initiatives, the next 12 months, more or less. Basically, in addition to sort of that core concept, what we're going to be doing is using this then to provide feedback to NRCS. So if you go out and we identify the soil map unit component as one soil, and you say, no, I actually know something about these soils in the area because my grandfather grew up here, that's not the soil. Well, there will be a feedback system back to NRCS, and they'll be able to use that to start to improve. Same for the ecological site. Same for the states, the state and transition models. It's been really frustrating for BLM because they've had no way to directly send their input on ecological site descriptions and state transition models back to NRCS. This will provide at least one mechanism for doing that. And there is a function where if you don't want to enter all the data on the phone, you can actually enter it on the web through the portal, and also edit your own data on the web. Something else that John Maynard is starting to work on now is basically taking all of the AIM and NRI data, which is, you combine all the different databases, so 30,000 or so plots distributed among a large number of ecological sites, and basically plot the values. So this is the number of plots in the gravel ecological site with perennial grass cover in these various percentage classes, okay? And then basically show where the plot that you collected with the land cover actually falls in that distribution. And then maybe do something to adjust those based on precipitation for that year. And again, that could get really complicated really fast based on some of the work that Deb has done. But again, we've got a lot of that research that we can start to bring into this to predict what your production or your cover would have been if you'd been on an undegraded site during a year without precipitation. So down the road, but actually we hope within the next 6 months or or less to at least have a basic feedback. So when you clicked on that results screen that I showed you, this would pop up. A lot of stuff here. And some of these are all different functions and features. Some are available now. Some will be available in February.